3.5, inverse functions. So this is kind of at the tail end of translations and transformations. But it still has to do with that because we're graphing. So inverse functions are kind of interesting because all you're talking about here is you're going to switch the domain and range. So basically what you're doing is you're switching the x's and the y's. That's it. And what you get is you get the inverse of the function. And how we often write it, and you'll see down here, it's called like f of -1, right? That's how we're going to write it when we're talking about inverses. And you have to use that terminology so then I know specifically that you're talking about inverse functions, right? Okay. So let's do example number 1. So we have 0, 1, 1, 2, 2, 3, right? Roster notation, right? All we're going to do with it is we need to switch and find the inverse of it. Well, all you do is you take the x's and the y's and you switch them. So 0, 1 is 1, 0, 1, 2 is 2, 1, 2, 3 is now 3, 2. That's easy when it's in roster notation. Now, what happens is when you get an equation. So for instance, we have f of x equals 5x minus 7. So this is just like y equals 5x minus 7. All you do is switch the x and the y. So if we switch the x and the y, we end up with x equals 5y minus 7. Well, we know that we have to have y by itself because it's always in the form y equals mx plus b, right? When it's linear. So to do that, you got to rearrange this. So yeah, we divide both sides, move the 7 over to the other side, divide both sides by 5. So we end up with x plus 7 over 5 equals y. So y is by itself. Yeah, but don't forget this is inverse. So we don't write it as y. We have to make sure we put in proper terminology, f of -1 of x, because that's the inverse, right, of y, and then we get our function there, right? So x plus 7 over 5. So the original was f of x equals 5x minus 7. The inverse is f of -1x equals x plus 7 over 5. So that's it. So linear, you just switch it back and forth. Okay. So example number 3, if we have a f of x equals 1/2 x plus 3, find the inverse if we plug in an 8. So 2 ways of doing this one. And you can pick whichever method you want when you're doing a question like this. Probably the best way is to take, so here's the original function, right? Y equals 1/2 x plus 3. Switch the x's and the y, so we switch the x and the y, right? Then we have to isolate y. So we just work through, move the 3, right? And then multiply both sides by 2. So we end up with 2x minus 6 equals y. Now, again, don't leave it in this form, right? You should always write it as f of -1 of x equals 2x minus 6. So now we have the inverse. Now, can we plug in the 8 into that? Yeah, we plug in, replace x with 8, do all the math, right? So f of -1 is 8 because that's what we're plugging in. So 2 times 8 minus 6. So we have f of -1 of 8 equals 10. That's the one method. And that method always works because it shows all the work. It shows that you can switch the x and the y. Now, here's an interesting one, method 2. The other thing, if you think about this way back at the beginning, if you switch the domain and range of a function, it's the inverse. Okay, so here's the thing. Method 2, if 8 is an input, right, it's the domain, if we're plugging it in, of f of -1x, it must be the output of the original function, right? So if 8 is the input in the inverse right here, it has to be the output of the original function. So we can do that. We can actually take the original function, and instead of plugging 8 into x, we're going to plug it into y. And then we do all the math, and we find out x equals 10. So it's quite a bit shorter, but you really have to understand about inputs and outputs or domain and range when you're dealing with that. Okay? So probably the best method is to switch the x and the y's, do all the math, rearrange it, and then do the math that way. Okay, next page. So inverses of functions, and we used to do something called the vertical line test, right? You would draw a vertical line. So for instance, look at this function down here. If we drew a vertical line, bang, right? It's going to cut it at one point. Yeah, we knew it was a function. Now, but here's the thing. When we're switching the domain and range, is it going to look differently? So for instance, this is f of x or y equals x minus 2 squared. So it looks like this. But if we switch the x's and y's, and I'll try to draw this on here. I'm just doing it on my computer, so it might not look too... It would look something like this when you do the inverse of it, okay? Now, if you did a vertical line test here, you notice it crosses at 2 points. So then that doesn't become a function. So when we're talking about inverse, you can use something called the horizontal line test of the original. If we did a horizontal line here and it crosses 2 points, when we do the inverse of it, it's not going to be a function. So unless you put restrictions on it. So the restrictions in this case is, here's what could happen. Everything either 2 or greater, or everything 2 or less. So here's our restrictions. X is greater than or equal to 2, or x is less than or equal to 2. If you put a restriction on it, then it will be a function. So for instance, if we had y equals x minus 3 squared, there's your restrictions. They would be either less or equal than 3 or greater than or equal to 3. If you had y equals x plus 4 squared, it would be either x is less than or equal to negative 4 or x is greater than or equal to negative 4. So all you do is when you want to graph these, you draw a y equals x line. We know how to draw y equals x, right? Y equals x, and you reflect all the values over that. So if we reflected that, you're going to see that it's not a function. So we have to put restrictions on this one, right? So in this case, if it's y equals x minus 2 squared to be a function, you have to either pick one or of those restrictions, either the left one or the right one. It makes no difference. Okay, so flip to the last page and you'll see this right away. So now let's graph the inverse of the function. So if you look here, this black line, right? If we had the whole thing, you could see it would be here. Here's our lovely parabola, but we have a restriction. Restriction is x has to be greater than or equal to 2. So basically, we're only talking about the right-hand side of this parabola. Now, if we want to, so here, if you look at the graph, you see how we removed all that left-hand side. Now, if the restriction was different, if it was x is less than or equal to 2, we would keep the left side and remove the right side. Now, all you do is when you're dealing with domain and range is you reflect it over you reflect y equals x line. So basically, you flip all the values, right? So 2 comma 0 becomes 0 comma 2, 3 comma 1 become 1 comma 3. Hey, 4 comma 4 doesn't change. Hey, that's an interesting term. Remember, the same on both graphs. It's called an invariant point. Get used to the terminology. 5 comma 9 now becomes 9 comma 5. And again, there's our restriction on this one. So it's really not that tough. The key part about that is you have to deal with the restrictions. You can't have the whole parabola, because if you do the inverse of it, you do not get a function. Okay? So that was 3.5.